So the reason why I'm interested in working on energy, not only because it's, we are running out of energy, also because of the impact in the, of the current energy use method on the environment. This is a picture of Beijing showing the good day and the bad day when the air is terrible. One of the main reasons, a big part of this pollution came from cars. So rather, if you have a very good energy storage possibility, so all the cars are not running on gas, but actually on battery and supercapacitors, the problem can be partially solved at least. So talking about this portable energy storage, currently we have two different approaches. Battery, which hold a lot of energy but charge up very slowly, and the capacitor that can be charged up very quickly but don't hold a lot of energy. So the solution for that, in my mind, is to go between a battery and a capacitor, which is called a supercapacitor, and that relies on electrochemical reaction, but really, really fast electrochemical reaction to store energy, so that you can store a lot of energy and also be able to charge up relatively fast. Looking at all the material that are being studied, ruthenium is very, very good, but it's too expensive. Looking at the other choices, we picked MnO2 as the material that we want to focus on. Theoretically, MnO2 has a very, very high capacity, 1380 Faraday per gram, but realistically, people can only achieve about 10 to 200 Faraday per gram usage in real devices simply because MnO2 is a very, very bad conductor. So you can only use the surface of the material, not the whole structure, whole material for the energy storage. So my approach is to use carbon material to solve this problem. I'm not the only one to do that. People use carbon nanotube, graphene, to improve conductivity of MnO2. Normally, they would have this carbon nanostructure, and they would glue MnO2 particle on it in order to really have a very conductive material. But turns out, once you glue materials on the carbon structures, you disrupted the connection path between the carbon structures so that you solve part of the problem, but not the whole problem. So what I found is that if I instead add an additional step by having MnO2 on graphene and then add a bare carbon nanotube, mix them together, I get a structure with a very high conductivity, a very good conductivity. And surprisingly, not only the material is very conductive, it's also very flexible and very, very strong. The strength of this material is as good as nylon film. See, this is the strength of this composite material that we make that's self-standing compared with nylon film. It's comparable. So that we actually have a very good, strong, and highly conductive film that we can use for energy storage applications. And we actually did that. I'll show you. Like we have this film. They are very flexible already. We put a separator there, and we put another layer of film, similar film, and just wrap it together, like roll it together, and we get a capacitor. And if you look at the performance of the supercapacitor that we are making, normally what other people do in a similar system is that whenever they increase the charging speed, meaning they increase the power density of the system, their energy density drop very, very quickly due to the low conductivity of the material. But with this really good composite that contains graphene, carbon nanotube, and metal oxide, we do still drop from 30 to 25, but it's not dropping that fast. Where are we standing? Okay, these are the DOE targets and the current performance of different batteries. Here the capacitor. And in the term of the energy density, we are already as good as a lead acid battery, but we can charge 100 times faster than that battery. So it's already, I think, the performance of this type of supercapacitors can already be used in, not in cars yet, because energy density is not high, but it can be charged really fast for bus, for like an electric scooter, and this type of supercapacitor is already, the performance is already there for that type of applications. So the basic idea is really to use this, really just the unique property, 2D graphene and a 1D carbon nanotube together, not separately, to improve the performance of the metal oxide material that are not that conductive. Okay, that's what I'm doing in the energy storage area. Thank you.